Hello students, in the previous video we started with units and measurement, and I told you about a physical quantity. What is a physical quantity? A quantity that can be measured. A measurable quantity is called a physical quantity, like mass, length, time, temperature, speed. All these are measurable quantities. So they are physical quantities. So also I said about three types of systems of units: CGS system, MKS system, and we also spoke about British system, FPS system. Okay, CGS, length, mass, time. It represents these three factors: centimeter, gram, second. MKS, meter, kilogram, second. This is that. FPS is not used nowadays so often in other countries, right? Foot, then pound and second. Second is common, time is common for all these things. And I also said there are 7 basic units. So what are those 7 basic units we studied about? One is length, okay, mass and time. These are the primary one. And then also we also said that electric current, ampere, then luminous intensity, candela, amount of substance, mole, and then we said temperature is Kelvin. So these are 7 quantities we are talking about. Now these 7 basic units are also called 7 dimensions of the physical world. What do you call it? 7 dimensions. Okay, so you will learn more and more, little bit the words, right? Now what are the 7 dimensions? They are 7 units. Yeah, basic units, fundamental units, right? Now length we represent in dimension method capital L, okay, and mass we represent with a square bracket capital M, and time we represent with a capital T. So L, M and T, these are the 3 things which we are going to use, 3 basic quantities which are going to use. Other than you have candela, you have Kelvin, you have ampere and you have mole. But in the primary case we are going to use now length, mass and time. And how can we derive other dimensional formula from these basic dimensions? Okay, so let us go step by step and you will understand better. Okay, so keep it in mind, MKS system is also called SI units, and I told you system, the international system of units. Now how am I going to use this? Let us say I take a simple example. I want to say, for example, speed. Let us define speed. Whenever you want to make a dimensional formula, you need to know first and foremost that the definition of the particular physical quantity. Speed. We know that speed is equal to distance traveled upon time taken, right? Now distance is length actually, so you write L divided by time, you write T. This can be written as L T power minus 1, right? Now let us take here speed. The dimensional formula is L T power minus 1. Okay, now what about velocity? What is the unit? What is the dimensional formula for velocity? Very simple. How do you define velocity? Velocity is, instead of distance, displacement upon time. Again, displacement or distance is nothing but length only, L T power minus 1. Now what is the difference between distance and displacement? Distance is actual path covered by a body, and displacement is the shortest distance traveled by the body. For example, I take a position A here, the body is moving to the point B and perpendicular it moves to the point C, and this is 3 kilometer and this is 4 kilometer, and the distance traveled is actual path traveled by the body. that is 3 plus 4, 7 kilometer. But what is displacement? The body was here and it has moved here. That is what the displacement is. This is the shortest distance AC, that is 5 kilometer. According to Pythagoras theorem, the triangle is right angled triangle. I hope you understand. This is how you move on from one point to another point. Okay, in 9th standard you have also studied acceleration. Okay, acceleration. How do you define acceleration? That is defined as change in velocity divided by time taken. Change in velocity, initial velocity, final velocity. Velocity is velocity. So what is the dimension of velocity? L t power minus 1, right? So we will take here L t power minus 1 divided by t. T is for time. That is equal to L t power minus 1. This goes up t power minus 1. That is equal to L t power minus 2. L t power minus 2 is the dimensional formula for acceleration. So these are derived one. Okay, now let me write here acceleration. For acceleration it is L t power minus 2. Okay, now let us move further from here. Yes, let me switch off the fan please. There is a small noise is coming. Yeah. Okay. Now from here I move to the definition of density. Okay, density. What is density? Density is mass divided by volume. Mass divided by volume. Now mass, we know LMT, mass is M. But what about volume? Very simple. Volume is equal to length into breadth into height for a cuboid. So volume is volume. Any other substance, material shape also you take. So length into length, that is L power 3. So keep this in mind. Now we can add here one more. Volume is equal to this L t power 3. Fine, this is it. So I write here mass upon volume M upon L power 3. So that is equal to M, L goes up, L power minus 3. So now the next definition which we are having is for density. Density is M, L power minus 3. I hope you understand. First and foremost, in order to find the dimensional formula of any physical quantity, you should know how to define it, right? So I will take for example now, let us say pressure. Okay, pressure. What is pressure? Pressure is equal to force upon area. Okay, now for this we should know force. Now first we will go to force. What is force? Force is equal to, according to Newton's second law of motion, F is equal to ma. Mass into acceleration. Mass into acceleration. Okay. So what is mass? M. And what is acceleration? L t power minus 2. L t power minus 2. So the dimensional formula of force is M L t power minus 2. So I will write here force, that is M L t power minus 2. So once I know the basic quantity, yeah, we derive one basic from derived quantity from basic quantity, and then again advanced derived quantities like this pressure. It is wanting you to have force. Now we calculated for the force, which is M L t power minus 2. So I write here M L t power minus 2 upon area. Oh, now area. Area is length into breadth or side squared for the square. So L into L, L square, L power square. L square we don't say, L power 2, L power 3, L t power minus 1, L t power minus 2, M L t power minus 2, M L power minus 3. So this is how you basically learn. Okay, now by area, area is L power 2, fine. So what you do is m L t power minus 2, L power 2 goes up, L power minus 2, that is equal to m L power 1 minus 1, that is L power minus 1, and t power minus 2. So what is the quantity you see? Pressure is m, I am writing here, pressure is equal to m L power minus 1 t power minus 2. Okay, now one more quantity I will do now, and then I will do one of the applications of the dimensional formula. Yeah, let us look at it. We will take, for example, work done. Okay, work is equal to, what is work? Force in physics, force multiplied by what? Distance moved by the body. Force multiplied by the distance moved by the body. What is force? M L t power minus 2 into distance is length, that is L, that is m L power 2 power 1 plus 1, which is 2, t power minus 2. Okay, now let me write here from this, yes, let me take here, work is equal, for this the dimensional formula is m L power 2 t power minus 2. Okay, now I have found work. Now I have to find out that the energy. What is energy? Energy is nothing but work. Energy is ability to do work. Energy and work are two sides of the same coin. In a coin, head and tail cannot be separated. Like that, work and energy cannot be separated. Whenever you do work, you have energy. Whenever you have energy, you do work. So they are same, one and the same. So energy also has the dimensional formula m L power 2 t power minus 2. Okay, but since we learned this much, I would like to bring a small one more quantity, that is momentum. Okay, momentum. What is momentum? Momentum is mass into velocity. Okay, momentum is mass into velocity, and force is mass into acceleration. So momentum is mass into velocity, L t power minus 1, that is m L t power minus 1. So I will write here momentum is m L t power minus 1. Okay, so I have done today some basic which you know already, you studied in rather 9th standard or 10th standard. Based on that, I have done these things, area, volume, speed, all these things. Okay, so I have done all these things. There are so many. You have hundreds and hundreds of quantities are there. Minimum you will be learning around 100 quantities, physical quantities in 11th, and you will learn around 100 physical quantities in 12th. So as we go by, we will be able to do that, because we should not try to memorize. If you memorize, I am telling you, in higher level physics and all, you will totally blank out. Yes, never memorize, understand. Okay, now what is the use of this dimensional formula? Is it for some fun we are doing? No, it has some applications. Now I am going to take only one application today. We can check the correctness of a equation. Whether an equation is right or wrong, we can correct it. We can check it. Okay, is it dimensionally correct? Yes, that can be tested. Okay, I am erasing this part. I think first I will do with these basic quantities I have taken. Right. Now tell me, the body is moving in a uniform motion with a uniform acceleration a. We have three equations of motion, right? We have studied V is equal to U plus AT. We studied S is equal to UT plus half AT square, and we studied V square minus U square is equal to 2AS. Okay, these are the three equations of motion. Now, what I am going to do, I am going to take the first one, V is equal to U plus AT, and I am going to check, is it dimensionally correct? So what we do, simple, velocity, final velocity, velocity is velocity, What is velocity? L t power minus 1. L t power minus 1 is equal to velocity, again initial velocity, L t power minus 1 plus A is acceleration, L t power minus 2. L t power minus 2 into time is t power 1. Okay, I got L t power minus 1 is equal to L t power minus 1 plus L t power minus 2 plus 1 minus 1. Right, now look at this formula. Yeah, yes, and we say the equation is dimensionally correct. What? Sir, L t power minus 1 is equal to 2 L t power minus 1. No, you can't add like that. Yes, you can't add like that. Each quantity is having same dimension, then the equation is dimensionally correct. Okay, so this is what the first one is. Now, on what concept are we saying like this? There is a rule called principle of homogeneity, right? And according to that principle, okay, let me erase this. Right, don't worry whether plus, don't add and all. Yeah, leave it as it is. Okay, now what is the principle of homogeneity says? Principle of homogeneity. It says that A plus B is equal to C plus D. A, B, C, D, all of them are some physical quantities. We just need it like this, that's all. They all should have same physical dimensional formula. Then the equation is correct. Okay, so this is what you should know, that we are not going to add, we are not going to subtract and then say that it is not correct or something like that. Okay, let me do one more problem for you. S is equal to ut plus half at square. Yes, watch. What is S? Displacement. Displacement is distance. Distance is length. So L is equal to U, initial velocity, L t power minus 1 into time is t. This first factor is over. Plus half A, acceleration, L t power minus 2 and time is t power 2. Okay, so we have got all these things. T power minus 1, t power 1 is cancelled, t power minus 2 and t square is cancelled. So simply we say L is equal to L plus L and the equation is dimensionally correct. Sir, again L is equal to L plus half into L. 1.5 L, no, we cannot include all this kind of numerical values and constants like that. Yes, in dimensional formula, there are certain limitations, right? And otherwise, it is very interesting concept. Yes, and we have to learn that. So, according to principle of homogeneity, the left hand side and right hand side have similar values, similar dimension. So, it is dimensionally correct. Okay. Now, let us try for one last problem in this video, and for you, the homework is what? V square minus U square is equal to 2AS. 2AS. Right. Now, let us see. Somebody says F is equal to MV. Oh my God. Somebody says F is equal to MV. We know that F is equal to ma according to Newton's second law. So we can check it dimensionally. What is force? See here, m L t power minus 2 is equal to mass is m and velocity is L t power minus 1. Are they equal? L, but t power minus 20 power. They are not equal. They are not same. So the equation, you write the equation is dimensionally incorrect. Okay, incorrect or wrong, you can write. So this is how you learn. So today I have done the first application of it, that to check whether a physical, for example, formula is right or wrong. Okay, to check dimensionally whether an equation is dimensionally correct, that we have done it. Okay, so in the next video we will come with more applications. Thank you so much.